Hello everyone, I'm Wang Si from Xiamen University, Malaysia, and today I'm going to have a presentation about sigma notation, product notation, and their applications. I believe all of you have heard of the story of young girls figure out the problem of consumption from 1 to 100. But as you can see, this problem is really messy to write it down because there have too many numbers. So, for the problems like these, here comes the sigma notation and the product notation. My whole presentation will contain 4 parts. The introduction of sigma notation, product notation, and then their application, and finally the summary part. Let's go back to our previous question. We can definitely know that there is some connection between all of these numbers. So why don't we just think all these numbers as a set from A1 to A100, and there must be some connection between this. We can write it down as A1 equals 1 and AN plus 1 equals AN plus 1 because every numbers behind equals to the previous number plus 1. So the consumption is A1 plus A100. Now we define the sigma notation as n starting from n to equals 1, which is the below 1, below the sigma notation, and the upper number above the sigma notation shows that the ending point is an. And the right hand parts an means every numbers before the consumption equals satisfy this form. Let's see some examples. A1 until to A100 equals to the sigma notation k starting from 1 to 100, and every number satisfied k. The for 1 consumption starting from the first number 1 ending up as the 4, and every number satisfies the form of 1. And about the square one, every number satisfy the form of k squared, and k starting from 1 and ended up at 4. About the properties of sigma notation, we can see as follows. The sigma notation of 2 can be written as 2 separately because the sigma notation truly is the consumption, and consumption is linear. The second properties, because the C, every numbers have the product of C, and we can just product the C out of our sigma notation. And the third property shows that every sigma notation can be written as separate sigma notations consumption. Let's look about the product notation now. Similar to the sigma notation, we define product notation as the simpler notation of a product to many numbers. And the numbers starting from A1 n equals 1 as the below, and ended up as n as the follow, and every numbers satisfy the form of an. Here's are the examples. What's more interesting is that we can use that product notation to note the factorial s of n. Here's are some properties. What's interesting is that we cannot just put C outside of our product notation because every numbers product C and they together product together. So there are C times n times C product. So we must to put C outside as C n squared. And now let's come to the application parts. First, the sigma notation used in Riemann sum. In calculus, we can know that the area below the graph, we can just approximate it as many consumption of many different triangle, and each triangle has the length of delta x, and the height of triangle is fxk. So we can simplify to written the area in the sigma notation, but when we try to calculate the integral, we must add it a limit n tend to be infinity in front of our sigma notation. And about the product notation used in probability, we know that if two activities are independent, the probability must be the product of all of them. But if we have many different activities, we can just simply write all the product into the notation of product notation. Yeah. And about the usage of product notation in the degree of polynomial, for polynomial that have factors r1, r2 until rn, we can write it in the form. And follows are the equation of the polynomial equals to 0 and the function of the polynomial. And as we can know, the degree of the polynomial is just simplified as the n. Now let's come to the summary parts. I wanted to further introduce that double summation, that is the nested sums. Two sigma notation together, that means we need to write the inside notation out and then the outside notation. But interesting is that we can exchange the position of these two sigma notation. Yeah. Here's are about the common mistakes about sigma notation and product notation. First of all is using the k and I in different equations, because that k and I doesn't means anything, but we use them as but we need to make them the same. We don't, yeah. And about the second one, because of the pi note, about the product notation, we needed to write the c out as the c squared, not only the c. And the third one, as we write them separately, the other one must be k equals m plus 1, not starting from m. Yeah. About the summary part, the sigma notation and the product notation isn't an invention, a new invention. It is just a simpler form that we can write as a bunch of numbers, their consumption and their production. But these numbers have a certainly satisfy one relationship. So we can just simply say that the sigma notation equals to addition and the product notation equals to multiply. Yeah, that's all. That's all my presentation. Thank you all for your listening.